3, 2, 1, 0. Welcome back to Mathematics Lifeline. Today, we're going to be going over the power rule for integration. We're going to start off this series on integration with the power rule because it's the most basic. Now remember, when you take a derivative, the power rule looks like this. The derivative of x to the n equals n times x to the n minus 1. So for integrals, we have something similar. Remember, the integral is just the antiderivative, right? So if you want to take away this n minus 1 in the derivative, you need to put an n plus 1 in the power rule for the integration. So the integral of x to the n is x to the n plus 1 over n plus 1 plus some constant. So let's do some practice. Here we have the integral of x squared dx. Remember from our power rule that we need x to the n plus 1 over n plus 1. So in this case, our n is 2, so we have x to the 2 plus 1 over 2 plus 1, which gives us x to the third over 3. Now remember, when you're doing integrals, you need to add a constant at the end, plus c. So your final answer is this. Now let's go to another example. Here we have the integral of 7 plus x to the fourth dx. What we can do with this is split this up into two integrals. The integral of 7 dx plus the integral of x to the fourth dx. So with this one, this looks a little weird if we're going to use a power rule because we don't see an x. But remember that x to the 0 is equal to 1. So we really have 7x to the 0, the integral of that, which is equal to 7x to the 0 plus 1 over 0 plus 1, which is just equal to 7x. That's the first part of our integral. Now the second part of our integral is x to the fourth, which looks a lot more classic. Our n is 4, so we have x to the 4 plus 1 over 4 plus 1, which is equal to x to the fifth over 5. So when we put all these together, we have 7x plus x to the fifth over 5. But don't forget the plus c. So now here's another case that you're not going to be able to use the power rule for. Let's go over here. In this scenario, you might think, well look, we have the integral of x to the negative 1 dx. The reason why we can't do it like this is because then we would have x to the negative 1 plus 1 over negative 1 plus 1, which is equal to x to the 0 over 0. And we can't divide by 0. So we know the power rule doesn't work for the integral of 1 over x. But remember from derivatives that the derivative of the natural log of x is equal to 1 over x. So since that integral is an antiderivative, what we actually can do here is say, okay, let's work backwards. So the integral of 1 over x dx is equal to ln of x plus some constant c. And then for the final example right here, we're going to introduce the definite integral. Here, instead of having nothing like we do for 1 over x, we have a 1 and a 3. That means you're doing the integral from 1 to 3 in your domain. So again, we can do this the same way we did the other example and split this up. So we have the integral from 1 to 3 of 10x minus the integral from 1 to 3 of x squared dx. This is dx too. When we do this, we end up with 10x squared over 2, which is equal to 5x squared, minus we have x cubed over 3. We did x squared earlier. But this time, instead of doing the plus c, we know we have this 1 to 3. So we have 1 here, 3 here. So what that means is we evaluate this part of the function at 3 and then subtract it from that part of the function at 1. So what we can do is just plug 3 in for all the x. So we have 5 times 3 squared, 3 squared, minus 3 cubed over 3, and that's the first part. That's when you plug in the 3. Then you need to evaluate it at 1. So because we're going to subtract these here, that's the rule for definite integrals. So minus, now we're plugging in 1 for everything. So we have 5 times 1 squared minus 1 cubed over 3. Now we can evaluate this. So this is 5 times 9, which is 45, minus 3 cubed over 3 is going to be 27 over 3, which is 9. So this right here is equal to 36, minus, right here we have 5 times 1 squared is 5, minus 1/3, which is really just equal to 14 over 3. So now we have 36 minus 14 over 3. And if we want, we can simplify this. So we could really make this 36 into 108 over 3 minus 14 over 3, which would end up giving us 94 over 3. So what that is the area from 1 to 3 over this curve. So that's the end of this first video on the power rule for integrals. We've discussed the basic power rule, and we've also discussed some exceptions to the power rule, along with introducing the definite integral. If you have any questions, be sure to leave them in the comments below. But until then, we'll see you on the next edition of Mathematics Lifeline. Later.